All right, guys, here we go. 12.3 inscribed angles. So let's do a little reviewing before we get into the nuts and bolts of this stuff. Make sure that you can see here. All right, so if you remember correctly from back earlier this semester, we could have something called a central angle. So a central angle is going to be an angle that is located in the center of the circle, right? So the vertex is located on the center of the circle. And that's going to open up to an arc, right? So this opens up to arc AB. And the way we label that is M, A, B, and we put a little arc over it. So the arc opposite the angle is always going to be the same measure. So if this is 60 degrees, this is going to be 60 degrees for the arc measure. If this is 100 degrees, this is going to be 100 degrees. And then also remember that if I have the whole circle, that the whole circle has an arc measure of 360 degrees, right? So what we're going to do now is we're going to, instead of anchoring the vertex in the center of the circle, we're going to anchor the vertex on the circle. So this is going to be on the circle now. And when it's on the circle, it's called an inscribed angle. So pretty much, the angle now is no longer the same as the arc. You're taking this and you're dragging it pretty much twice the distance from here to here. So what that's going to do is it's going to make this angle, think about it, if I drag this dot this way, it'll make this angle half as big as the arc. So if this is 30 degrees, the arc will be 60 degrees. If this is 160, this will be 80, right? Yeah, that's it. So the measure of the angle, if it's inscribed, equals 1/2 the measure of its, we'll call this AB, of its, we call that the intercepting arc. So if you have the angle and you want to find the arc, you double it. If you have the arc and you want to find the angle, you half it. Cool. All right, we got a couple examples here, basic examples, and then we'll make it a little bit more difficult per usual. So find the measure of RT. So if you look at it, angle S intercepts RT. Let's go ahead and let's highlight that. So that's kind of the intercepting arc that I have. So think about it, we're going from an angle to an arc, and it's on the circle, it's inscribed, so all I have to do is double it. So if this is 63, this will be 63 times 2. So that'll give me 126 degrees. Same thing here, we got an inscribed angle because the vertex is on the circle. Here's the intercepting arc, WY, and that's what we're looking for. Oh, we're looking for WX, the measure of WX. So WX, no, we probably want WY. Let's go ahead and fix that real quick. So we want WY. So if this is 57, this will be double 57, so this will be 57 times 2, so that'll be 114. So WX, 114. Next one's a little trickier, right? So we want to find the measure of angle P, and angle P is intercepted by this arc right here, NQ, but we don't know what NQ is yet. But if we think about it, we know that all the way around is 360, and there's 3 pieces. We know 2 of the pieces, so I can just do 360 minus 100 minus 120, and that will give me 360 minus 100 is 260, minus 120 is 140. So that'll give me this as 140 degrees. And then I have to take it a step farther. If I'm going from the angle, the arc back to the angle, I take this and I divide by 2. So angle P is going to be equal to 70 degrees. Pretty simple. If I give you the arc, divide by 2. If I give you the angle, multiply by 2. Okay. Let's keep it going. Find X, angle B. So here we're gonna kind of blend this idea with the idea of my triangle here. So if this is 40, that means that, oh, this is 40, that means that this has to be 80 degrees up here. And now, this is 200. So you can do this a couple different ways. Because this angle is 200, or this arc is 200, I can work backwards and I can find this angle right here, or I could subtract from 360 and find this arc right here. So it doesn't really matter how you do it. I'll find arc CA. So I'm going to do 280 minus 360. So if I go 360 minus 280, that'll give me 80. And now that I know this is 80, I can work my way backwards and get that this is 40. And then if you wanted to check yourself, so angle B is going to be 40 degrees. If you wanted to check yourself, you could get, because this opens up to that, that'll be 100. Add those three together, you get 180. Cool. All right, next one. Find angle P and the measure of PO. So, all right, find angle P. Angle P is opposite this arc right here, so we're going from the arc back to the angle. Angle P has to be 70 divided by 2, which is 35 degrees. Angle P is 35 degrees. And the measure of PO, so I'm going from 56, I'm going from the angle to the arc, so I have to take this, multiply by 2, that'll give me 112 degrees. Cool. 6, find CF, so from C to F, and angle C. We gotta look for angle C. So this one's very similar to the one we just did. So we're going from the angle, it's intercepted by this arc right here, so this has to be double, so CF has to be equal to 80 degrees. And then we're going from 98, and we're working backwards, so this has to be 49 degrees. Because I take 98 and I divide by 2. C opens up to 98, and 98 alone. Cool. Okay, now what we're going to do is we're going to, you can figure these, there's 3 little corollaries that go along with this. You can figure these out pretty easily. If you didn't know them, you'd be fine, but it kind of makes your life a little bit easier. So the first corollary, which is just like a rule, an additional rule. If I have the same arc, so let's say I have this arc right here, and I have the same arc opening up to different angles, these 2 angles must be congruent. And if you think about it, it makes sense. This is opening up to, let's say this is 50 degrees. This angle is opening up to 50, so this has to be 25. This angle is also opening up to 50, so this has to be 25. Therefore, these 2 are congruent to each other. There's 2 more corollaries. If I have a diameter, the diameter will always split the circle into 2 arcs that are 180 degrees each, right? So if I have an inscribed triangle inside of a semicircle, I know that this angle has to be 90 degrees because it opens up to 180 degrees. And you're taking it, pulling it back, right? So if you have an angle inscribed inside of a semicircle, it has to be 90. And the last one, this one's actually really useful. If you have any quadrilateral, it doesn't matter. First of all, look at this angle. This angle right here opens up to this arc right here. And this angle right here opens up to this arc right here. So if you look at it, you can see that the whole circle is taken care of. So because it opens up to 360 degrees and they're on, these 2 inscribed angles have to be supplementary. They have to add to 180 degrees, right? So if they open up to the same arc, they're congruent. If they open up to a semicircle, it has to be 90. And if you have a quad inscribed inside of a circle, the opposite angles have to be supplementary to each other. Okay? Cool. So let's do a couple more examples here, and you guys can try the math Excel. So look, angle T and angle U both open up to SV. So because they both open up to SV, they must be congruent to each other. So if I wanted to find x, I can go 2x plus 15 equals 3x minus 5. I'll get the 2 over there, so I got x equals 20. Now if I want to find angle T, that's this angle right here, it's also the same as angle U. 2 times 20 plus 15. So 40 plus 15 gives me 55 degrees. Next one, find A and B. So finding angle A, finding arc A, so you have to find A before you can find B. So that's going to be this right here, arc PT. So again, we're going from 60. 60 opens up to this, so this has to be 120 degrees. So that'll be 120. And now B, think about it, B opens up to a slightly different arc. B opens up to the 120, but it also opens up to this part right here. So this arc is going to be 150, 120 plus 30. So if I wanted to find B, I just take 150 divided by 2, and I get 75 degrees. Cool. Nice, good stuff so far. Next one, so B, that we're going to use corollary 2 here because B opens up to our semicircle. B has to be 90 degrees, half of 180. C opens up to 122, so if I want to find angle C, I can go ahead and subtract, and I get this to be 61 degrees. And then there's a couple different ways you can find A. You know that this is 180. So you can do 360 minus 122 minus 180. That'll give you A. So 360 minus 180 minus 122. That'll give you 58 degrees. And the fun part about this is you can actually do it a couple different ways. You know that that's 90, that's 61. So you could actually find what this angle is if you do 180 minus 90 minus 61. You can get this to be 29 degrees. And then we're going from the angle to the arc, so you just double it and you get 58. Doesn't matter how you do it. Okay? Cool. Got a couple more. These will be fast. Find A, B, and C. Find A, B, and C. So cool. Let's go ahead and we'll start with, I can find A real quick. This is 39, and it opens up to my arc A. So 39 times 2. This will be 78 degrees. B opens up to a semicircle, so B has to be 90 degrees. A has to be 78 degrees. And then C opens up to this part right here, which isn't labeled. We don't know how big it is, but we do know that this is a semicircle. So this is 180 minus 50 is 130. And then we work backwards, so we get this to be 130 divided by 2, 65 degrees. Cool. All right, let's use our corollary 3 for these. So you have your rectangle, right? That's interesting. 90. Okay, so this is 92. We're going to find A, B, and C. So I know that A has to be supplementary to 92, and C has to be supplementary to, I wonder why there's 2 A's. C has to be supplementary to 102. So if I go 102 minus 180, I'll get 78, so I just found this to be 78 degrees. And then same thing here, if I do 180 minus 92, I get 88 degrees. Very good. So now I know that this is 70 degrees, so I know that this opens up to 140 degrees over here. This is 102 degrees, so I know that this will have to open up to 200, and from here to here, this has to be 204 degrees. 102 times 2. So if I do 204 minus 140, I get 64 4 degrees. Right, and then I can kind of keep working to figure out how big this needs to be. I know that this part's 64. I know that this is 140. This is 70, so I know that from here to here, I know that that's 140 degrees. Cool. And then you can just subtract to figure out what B is. Nice. All right, let's keep going here. 12. So, again, this is a quadrilateral. These two are going to be supplementary, so if I go 2x plus 58, I can set that equal to 180. So if I do 58, 180 minus 58, divided by 2, I can get x to be equal to 61. And then same thing here, these two are opposite in my quadrilateral, so I can add those together and set them equal to 180. Do not set them equal to each other, that's not true. So I can go 2x plus 16 plus 2y plus 16 plus 3y plus 4 equals 180. So I got 5y plus 20 equals 180. Means 5y equals 160. 160 divided by 5, 32. There you go. Okay, the last little part here. Yep. It's going to be perfect timing-wise. Last little part here, we're going to have an inscribed angle, but this line right here is called a tangent. These look a little strange. We're looking for QPR, so QPR, we're looking for this angle right here. Again, don't overthink it. Just say, okay, I'm looking for the angle. I have the arc, so if I go from the arc to the angle, 148 divided by 2, I get 74 degrees. Same thing here, but I'm going from the angle to the arc. So I take this and multiply by 2, so I get 128 degrees. Last one, find out what this x is. So this is the first time the central angle popped up. Since this is 90, I know that this is 90. This is 160, so if I do 90 plus 160, I'll get this outside area here. 90 plus 160 gives me 250, hopefully, yep. And then think about it, how much do I have left? So if I do 360 minus 250, I get 110. And since x is on, even though it's made up of a tangent, right, x is on the circle, so all I have to do to find x is take 110, divide by 2. I get 55 degrees. All right, cool. Let me know if you have any questions. 18 minutes, pretty good. Peace.